Hi to everyone. I welcome you to my video about discrete probability distributions. This is Senior Huntington, your accounting tutor. Now, in our previous video, we looked at binomial distributions, and we said that in a binomial experiment, there are only two possible outcomes, conventionally labeled as success and failure. And we also say that the probabilities of success and failure remain the same from trial to trial. In today's video, we are looking at another important discrete probability distribution, which is known as the Poisson distribution. Now, Poisson distributions are useful in problems that deal with finding the number of occurrences of a certain event over time or space, where space refers to area or region. And for simplicity, we call these occurrences successes. The Poisson process. Now, an experiment satisfies a Poisson process if the number of successes within a specified time or space interval equals any integer between 0 and infinity. Don't forget that when it comes to Poisson problems, there are infinite number of possible values. Then the number of successes counted in a non-overlapping intervals are independent. The probability of success in any interval is the same for all intervals of equal size and is proportional to the size of the interval. Now, for the Poisson distributions, for a Poisson random variable x, the probability of x successes of a given interval of time or space is given as. So if you want to calculate the probability of x successes for a Poisson random variable x, the formula is E that is exponential power negative mu times mu power x, then over x factorial, where x, those are the number of successes over a given interval of time or space, mu, that is the mean number of successes, and E equals 2.718, and that is the base of the natural logarithm. Of course, just like the binomial random variable, we have simplified formulas to calculate the variance as well as the standard deviation of a Poisson random variable. In other words, here we are looking at the summary measures of a Poisson random variable. One interesting fact is that the mean of the Poisson random variable is equal to the variance. Now, the summary measures, if x is the Poisson random variable, then the expected value of a Poisson random variable x equals to the mean. Variance of a Poisson random variable x equals to sigma squared. But remember, as I've told you, that the variance is equal to the mean. Then the standard deviation of a Poisson random variable x equals to sigma, which equals to the square root of the variance. We have a simple illustration here. They are telling us that the police have estimated that there are 12 major accidents per day on a particular 10-mile stretch of a national highway. 12 major accidents per day on a particular 10-mile stretch of a national highway. Suppose the incidence of accidents is evenly distributed on this 10-mile stretch of the highway. Find the probability that there will be fewer than 8 major accidents per day on this 10-mile stretch of the highway. Find the probability that there will be fewer than 8 major accidents per day on this 10-mile stretch of the highway. Now, from our formula of calculating probabilities of x successes over a given period of time for a Poisson random variable, we can define the probability that there will be fewer than 8 major accidents per day by using the approach below. Of course, here we find probability of x less than 8, which is the same as the probability of x less than or equal to 7. probability of x less than or equal to 7 equals to the probability of x equaling to 0 plus the probability of x equaling to 1 plus the probability of x equaling to 2 plus the probability of x equaling to 3 plus the probability of x equaling to 4 plus the probability of x equaling to 5 plus the probability of x equaling to 6 plus the probability of x equaling to 7. Remember, we are calculating the probability that there will be fewer than 8 major accidents per day. In other words, we are interested in the probability of x being less than or equal to 7. Don't forget your mean, the mu, equals to 12. So if you want to calculate the probability of x less than 8, this will equal to this. Of course, I'm just substituting in the formula where there is x, I'll put 0, 1, 2, 3, 4, 5, 6, up to 7. So we add all those probabilities of the x values, then we come up with the probability of x less than 8. And the probability of x less than 8, or the probability that there will be fewer than 8 major accidents per day, will equal to 0.085. So you can work out that. Then you come to 0.0895. That is the probability that there will be fewer than 8 major accidents per day. Then part B of the question, find the probability that there will be more than 2 accidents per day on a 1-mile stretch of this highway. Now there is a change, a slight change in the question. This time it's not a 10-mile stretch of this highway as in the previous part or as in the original question. Here we are looking at on a 1-mile stretch of this highway, meaning that we have to find out the number of accidents on each and every day, but on a 1-mile stretch of this highway. We still use the same approach of calculating the probabilities of successes of a Poisson random variable x. Our formula is there for calculating the probabilities, but here we want to determine the probability that there will be more than 2 accidents per day. Of course, here what we are calculating is the probability of x greater than 2, because they're telling us probability that there will be more than 2 accidents per day. So it is probability of x greater than 2. And of course, due to the fact that in a Poisson problem, we have infinite number of possible values, we use one of the probability rules that when we add all probabilities, they should always add to 1. So here the approach we use is getting 1 minus, because all probabilities have to add to 1, so we get 1 minus the probability of x equaling to 0 plus the probability of x equaling to 1 plus the probability of x equaling to 2. Remember, we are interested in the probability that there will be more than 2 accidents per day. So our probability of x greater than 2 equals to 1 minus the probability of x equaling to 0 plus the probability of x equaling to 1 plus the probability of x equaling to 2. However, in this problem, our mean changes because we want to get the number of accidents on a particular day on a 10-mile stretch of the highway. So meaning that our mean will equal to 12. Remember, 12 was the initial mean for a 10-mile stretch. So meaning that if you want to get the mean on a 1-mile stretch, I'll get 12 over 10, giving us our mean of 1.2. So it's this mean which we are going to use on this problem to come up with the probability that there will be more than 2 accidents. Remember, your x values, that is 0, 1, and 2. So the probability of x greater than 2 will equal to that. That is 0.1205. Our mean is 1.2. That is on a 1-mile stretch, don't forget, because we have said that we want to come up with the probability that there will be more than 2 accidents per day on a 1 mile stretch of this highway. So our mean will be 1.2, and our x values will have 0, 1, and 2. When you compute, you come up with 0.1205 as the probability that there will be more than 2 accidents per day on a 1 mile stretch of this highway. So that is it for the Poisson probability distributions. If you like this video, then hit the like button and subscribe. Thank you for watching. Senior Huntington.